Okay, here we go. So we're going to review Unit 1. Your review is by big idea and then essential question. So the first big idea is that science is a process of inquiry, observation, experimentation, and analysis. So what we talked about was the scientific method, right? So essential question 1. How do I recognize patterns and trends to draw conclusions using the scientific method? So the first thing is we got to know what the scientific method is, right? So I included the 5 steps to the scientific method that we talked about. I know sometimes there are more than 5. As long as you have these 5, if you have anything additional, I will not count off for that. You just have to have these 5 at least, and in this order. So first is to ask a question or make an observation, followed by writing your hypothesis, doing your experiment, record and analyze your data, and then draw a conclusion. So determine whether or not your data supports your hypothesis or doesn't support your hypothesis. We discussed the importance of retesting to validate your results. So we did our lab with our popsicle sticks pencil holder. And we've discussed a lot about the fact that, a lot of the groups couldn't recreate someone else's because the directions weren't specific enough, or there were things that changed. So you have to make sure that when things are retested, they have to be retested exactly the same way as before, because the more times you get the same results from the same experiment, the more valid the results become. So remember that repetition equals validation. Okay. We're also going to use graphs to determine patterns and trends, graphs and tables to determine patterns and trends. Okay. Essential question number 2, how do I design a controlled experiment to appropriately test a hypothesis? So we talked about a lot of different vocabulary terms that are important for you to know. First one is the control group, which is the group that's typical. So the example that I gave you was about the farmer who wanted to change the fertilizer that he used on his crop. And so what was typical was the crops that just didn't have a fertilizer or had the old fertilizer, okay? That's your control group, whatever's typical, okay? Then the experimental group is the one that has the one variable change. So our experimental group in that example would be the field that had the new fertilizer on it. Your independent variable then is the one that is changed, so the thing that's different between the control group and the experimental group. So that in that particular example, it would be the fertilizer itself would be your independent variable. The dependent variable is how you determine your results, or what changes due to the independent variable. So determining the results in this case would be the growth of the plants, right? Did the crop grow better with the new fertilizer or not? The control, so different from the control group, this is the control, are the parts of the experiment that do not change. So everything else has to stay the same. So in that example, the water, how much water the crops get, sunlight, you don't want one field to be in the shade and one field to be in full sun. Everything else has to be the same. Type of crop would need to be the same. Remember that we can only have one independent variable, one thing to change. Does anyone remember why? Why can you only have one independent variable?
Yeah, two things don't change the results.
Right, if you have two, or even more than that, if you have anything more than one, you won't know what causes the results. Very good.
Bless you, let's see. Bless you.
Okay. Essential question 3 is how do I make observations and calculate data involving metric units? So we talked about remembering the sentence, King Henry died by drinking chocolate milk. It puts all of those metric units in order, or at least the ones that you need to know. And we talked about how the first letter of each of those words represents the prefix, right, of our metric units. So kilo, hecto, deca, the base unit, deci, centa, and milli. If the unit is getting smaller, so if you're moving to the right across that list of units, you're going to move the decimal point to the right. If the unit is getting bigger, so like going from gram to kilogram, moving to the left, then you're going to move the decimal point to the left. You have 3 base units that you're responsible for knowing: grams, meters, and liters. So if you see any of those as part of your metric conversion, you'll know to go to the B on your chart, which is for the base unit. Big idea too is that all matter can be organized into groups based on properties and composition. So we talked about properties first, and then we talked about composition. So essential question 1 is, how do I use physical and chemical properties to identify or describe an unknown substance? So all substances have a unique set of physical and chemical properties. So we played the Who Am I game, where I gave you some physical and chemical properties, and then you decided what you thought the substance was. Physical changes or physical properties do not change the substance. So phase changes, color, anything else that's physical, so length or shape. Chemical changes or chemical properties change the substance at a molecular level. So combustion, the leaves changing color is a chemical change or chemical property right now. Why do leaves change color? Yeah, that's exactly right. The chlorophyll breaks down, so chlorophyll is green. The chlorophyll breaks down, so they lose their chlorophyll, and that's what causes them to change color. So that's a chemical property of a leaf, that it will change color when it loses its chlorophyll. Essential question 2 is, how do I classify matter based on composition? So we talked about determining whether or not a substance is a pure substance or a mixture. And then from there you can classify it even further. If it is a pure substance, you can classify it as an element or a compound. Some examples of elements are oxygen, hydrogen, any of the elements straight from the periodic table. Compounds are combinations of those elements, so H2O, so pure water, H2O, carbon dioxide, carbon monoxide, sodium chloride, which is salt, sugar. Those are all examples of compounds. In a mixture, each piece does not lose its identity. So Chex Mix, salt water, air, tap water would be an example of a mixture because it's got other things in it. There are two types of mixtures: homogeneous, which has uniform composition, so salt water would be a good example of that. And then heterogeneous, which does not have uniform composition. So we used our Chex Mix as an example of that, because even though all of you got cups of it, they weren't all the same. The subscript 2, or like carbon dioxide and be like that. It represents the number of atoms that there are. So there's 2 hydrogen atoms and 1 oxygen. We'll talk about that quite a bit more in the next one. Essential question 3 for this big idea was, how do I calculate density of various objects? Density is a physical property. And the units that we used were grams per milliliter or grams per centimeters cubed. But I want you to take a look up here really quick. This kilograms per liter. So kilograms is 3 times bigger than grams, right? And then liters are 3 times bigger than milliliters. So you can use kilograms per liter. We didn't use it in any of our practice problems, but the reason I'm showing it to you now is because on Monday, the first part of your test is a performance-based part, so it has it's an interactive lab, virtual lab online that you have to complete. And everything they have is in kilograms per liters, and I can't change it. Like it won't let me change it. So you're going to see kilograms per liter on Monday. The calculations are all the same. It's just simply the units that are different. So I don't want you to think you have to do any kind of conversions. Kilogram per liter is the same as gram per milliliter in terms of, it's just 3 times bigger. So you don't have to make any conversions on Mondays. I didn't want you to be confused about that. So that's why I have kilograms and liters up there. I know it's not like, again, I know it's something that we talked about yet, but we will see it on Monday. The density of water is 1 gram per milliliter. If the density of a substance is greater than 1, it will sink in water. And if the density of a substance is less than 1, it will float in water. Big Idea 3 says that energy changes the states and interactions of matter. So we talked about the states of matter, solid, liquid, or gas, and then how they do phase changes, and then whether they're endothermic or exothermic. So essential question 1 is, how do I use the kinetic molecular theory to describe matter's behavior in each state? So let's talk about what the states are first. Solids have a definite shape and definite volume, and the particles move around less because they are so close together. Liquids have an indefinite shape and indefinite shape, definite volume. Indefinite shape, definite volume. They take the shape of whatever container they're in. The particles will move around more than a liquid. There's enough space they can kind of slide over and around each other. They don't move as much as in a gas. Gases have an indefinite shape and indefinite volume, and particles move a lot due to the relatively large distance in between particles. And I say relatively because it's relative to the size of the particles, right? Molecules are small, so the space doesn't seem big, but it's big in comparison to the particles themselves. KMT stands for kinetic molecular theory, and it states that when heat is added to the substance, the molecules will move faster. So more heat, the faster the molecules will move. last one. How do I describe endothermic and exothermic changes in matter? So yesterday we talked about endothermic changes being the ones that absorb heat. They take in heat. Endo means inside. So they take the heat in order to be able to do whatever the phase change is. The endothermic phase changes are melting, which is solid to a liquid, vaporization, which is liquid to a gas, and then sublimation, which is solid to a gas. And then the exothermic phase changes release heat, and those are freezing, so liquid to solid, condensation, gas to liquid, and deposition, which is gas to solid. So on your chart here, remember that your endothermic phase changes are going up the chart, so that's increasing your heat energy and increasing your temperature. And then your exothermic are coming back down. When you're finished copying this one, if you would open up Google Classroom, I want to show you where your other review paper is. So it's attached to the same classroom assignment. It's just a Google Doc.